discuss more about the statistical control charts. So in the last session we discussed about the variable control charts and about the attribute control charts, and I gave you some of the examples, and also we discussed one example about the X bar chart when you are given with a data set, how to construct your statistical control chart. So today I'm going to discuss about more on control charts. So if you can remember, I told you in the last session, when you are constructing the control charts, we have factors, right, in the equations. When you are constructing the center line and when you are constructing the upper control limit, lower control limit, you are given with a specific equation for each control chart. So in those equations you have some of the factors, and those factors you have to read from the factor tables. So today I'm going to explain you one example how to construct a R chart using the factor table, right? So if you can remember, when we were discussing about the quality control chart, so the first thing we discussed was the X bar chart. So if your data set, when you are given with the data set, if you know the standard deviation and mean of the population, and when you are constructing in the X bar chart, you can use the mean and the standard deviation of the population. In that case, you can see the center line is equal to mu, that is the population mean value, and the upper control limit is equal to mu plus 3 times sigma over root n, where the lower control limit is equal to mu minus 3 times sigma over root n. So in that case, we can see, since we are interested in 3 sigma control limits, that's why we have used 3 times the standard deviation of X bar, that is sigma over root n, in order to construct the upper control limit and the lower control limit. And if you take this 3 over root n, that is a factor which is changing due to the sample size, so you take it as a, right? So if you rewrite the same equations for the X bar chart, you can write the upper control limit as mu plus a times sigma, where the center line is mu, and the lower control limit is mu minus a times sigma. So you can see here I have given you the new set of equations. So this a value, that you can directly read from the factor table. So if I show you the factor table, you can see in the first column you have the sample size, and in the second column you have the a value. So for an example, if the sample size is equal to 5, a value is equal to 1.342. So you can directly substitute that to this equation, and if you know the population mean and the standard deviation, you can construct your control chart using these values. And to construct the R chart when with the standard value sigma, that is when you know the population standard deviation, and again if you are interested in constructing the R chart, again you can use the factor table, that is in this case you take sigma as R bar over D2, right, where D2 is the mean of the distribution of the relative range, and again you can take the if you take the standard deviation of the range, that is equal to d3 times sigma, right, where d3 is the standard deviation of the distribution of the relative range. So that is when you are constructing your R chart, when the population standard deviation and population mean are known factors, you can take the center line as d2 times sigma, right, and the upper control limit you can take as d2 sigma plus 3 times d3 sigma, and where the lower control limit is equal to d2 sigma minus 3 times d3 sigma. So you can see where since the mean of the distribution is equal to d2 sigma, we have replaced the mean value by d2 sigma and the standard deviation by d3 sigma, right? But here if you look at the factors, you can see if you take the upper control limit, since sigma, that is the population standard deviation, is a common factor, you can take it out. So you have d2 minus 3 times d3, and here if you take the lower control, if you take the upper control limit, if you take sigma out, you have d2 plus 3 times d3. So if you take this factor, we can rename it as d1, and d2 plus 3 times d3, you can rename it as d2. Right, that is the upper control limit, we can write it as d2 times sigma, the center line simple d2 sigma, and the lower control limit, that is d1 sigma, right? Again, if you pay your attention to the factor table, you can see, you can read capital D1, capital D2, and also when it comes to the center line, you have to know the value of simple d2. So if you look at this, the simple d2 values are also available in the factor table, right? So you can just read the values from this table and substitute for the equation to construct the R chart. But here you are constructing the R chart using this equation when the population standard deviation is known, right? And then the next thing is we discuss about the X bar chart and the S chart as well. So I told you, when you have a process and when you are given with the data, the first thing that we do is we go for a R chart, and we construct our R chart and check whether our process is in control, right? And if our process is in control, no problem, then we go for X bar chart, and then we again check whether our process is in control or out of control. But when you draw your R chart, when your process is out of control, you have to stop calculations and check the causes for this out of control signal. At the same time, I told you, if your sample size is greater than 10, right, we prefer S chart rather than constructing a R chart, because we know when you have a big data set, or when you have a huge distribution, range is not a good estimator. So because of that, we go for the S chart when you have more than 10 observations in your sample, right? So in that case also, when you construct a S chart, especially if the sample standard deviation, population standard deviation is not known, is unknown, we can go for a S chart, right? So in that case, if you want to construct the S chart, what you have to basically do is, there are different cases, right? Sometimes let's say, when you take a data set and when you want to construct the sample, when you want to calculate the sample standard deviation, we know the sample variance is equal to this equation, right? That is, you have to subtract the mean from each and every observation, take the squared value and take the total of the squared values, divide by n minus 1. Right, so we know when you take the population variance, right, the sample variance is an unbiased estimator for the population variance. But since we are interested in the standard deviation, so after calculating the sample variance, we can take the square root of this to take the standard deviation value. But the standard deviation is not an unbiased estimator for the population standard deviation. Alright, so let's say if you have a normal distribution, right, then if you take the sample standard deviation, what we actually estimate is C4 times sigma, where sigma is a constant which is depending on the sample size n, because we know it's not an unbiased estimator for the sample population standard deviation. So in that case, if you take the standard deviation of S, we can write it as sigma times square root 1 minus C4 to power 2, right? So that is, the special case is when, if you know the population standard deviation and if you want to calculate the control S chart, right, using the population standard deviation, in that case the center line is equal to C4 times sigma, right? Center line is equal to center line is equal to C4 times sigma. And also when you are constructing the upper control limit, that you can construct using this equation, that is C4 times sigma plus 3 sigma square root 1 minus C4 squared, right? And the lower control limit, C4 sigma minus 3 sigma square root 1 minus C4 square. So using these two equations, you can construct the upper control limit and the lower control limit, and also the center line using the equations. And you can see, just as in the previous case, if you look at the upper control limit and the lower control limit equations, C4, you have sigma. So sigma is a common factor. So if you take sigma out in the upper control limit equation, you have C4 plus 3 times square root 1 minus C4 squared. And if you take sigma out from the lower control limit equation, you have C4 minus 3 into square root 1 minus C4 square. So these two you can take as B4 and B6. Because if you look at the factor table, you can read B4 and B 6 values, B5 and B6 values in the factor table, right? B5 and B6 values in the factor table. So you can directly substitute these values to the equation. That is, if the population standard deviation is a known factor, when you are constructing the S chart, the central line is C4 times sigma, upper control limit is B6 times sigma, and the lower control limit is B5 times sigma, right? So if the population standard deviation is an unknown factor, and then when you are given with a data set and if you are still asked to construct the S chart, then what you have to do is you have to calculate the sample standard deviation values, right? In that case, for each sample, first you have to calculate the sample standard deviation values, and then you have to take the mean value of the sample standard deviation. That is, you have to take the total of all the standard deviations and divide by the sample size, which will give you the mean value of the sample standard deviation. So in that case, your center line would be S bar, that is the mean value of the sample standard deviations, and when you are constructing the upper control limit, that is equal to S bar plus 3 times S bar into 1 minus C4 squared, the whole thing square root over C4, and the lower control limit S bar minus 3 times S bar into square root 1 minus C4 squared over C4. So you can see in the upper control limit and the lower control limit equations, you have S bar as a common factor. So if you take S bar out, you have 1 minus 3 times square root 1 minus C4 squared over C4, and here if you take S bar out from the upper control limit equation, you have 1 plus 3 into square root 1 minus C4 squared over C4. So these two factors we can name it as B3 and B4. Right? So if you rewrite the equations, we have the upper control limit. I'll take this into the next page. Right, so that is, we have when the population standard deviation is unknown, and if you are constructing the S chart, in that case you can have the center line as S bar and the upper control limit as B4 times S bar and the lower control limit as B3 times S bar. Right, so actually these B4 and B3 are equal to B6 over C4 and B5 over C4. Right, so these equations if you have a look on the factor table, you can see the B4 value, the B3 value all up there, right? So you can just substitute after finding the mean value of the sample standard deviation. You can substitute them here and find the control limits. Now in this case, if you are constructing the S chart together with the X bar chart, you can easily construct the X bar chart with these values. That is, the center line would be the mean value of the means, right? That is what I have denoted here, X double bar. And then the upper control limit, mean value of the mean, that is, you take the total of all the mean values, divide by the number of samples, plus 3 into S bar, that is the mean of the sample standard deviations, over C4 root n, where the lower control limit is X double bar minus 3 times S bar over C into root n. But in these two equations, if you take this 3 times 1 over C4 times root n, that you can consider as another factor in the factor table, that is A3. So I can rewrite the equations of the control limits, that is, the center line is again X double bar and the upper control limit is equal to X double bar plus A3 times S bar and the lower control limit is X double bar minus A3 times S bar, right? So if you wonder whether you have to remember all the equations for the final examination, it's like this. You should remember these final equations, right? You do not have to remember equations in between the first step and the final step, right? That is, if you are going to construct a S chart, when the population standard deviation is unknown, you have to remember these are the control lines. And if you are going to construct the X bar chart with the sample standard deviation, then these are the values, or these are the control limits, right? So you have to only remember the last step, right, when you are constructing these control charts. These, if you, for an example, if you take these steps, you don't have to remember them, right? If you want them for your calculation, I will mention them in your exam paper. So you have to remember only the last step, that is what are the control limit equations when you are constructing R chart, when the sample, when the population standard deviation and mean are available, and if not, what are the control limits, and the same thing for the S chart as well, how to construct the S chart with the population standard deviation and the sample standard deviation, and how to construct the S bar chart with sample standard deviation. So those final equations you have to remember, right? So we'll do one example and see, then it will be clear for you, right? So I have already uploaded this into your cal. You can have a look, right? So if you look at this one, it says following table presents the inside diameter measurements of forged automobile engine piston rings, each sample or subgroup of 5 piston rings. We will use these data to illustrate the construction and the operation of X bar and S chart. Right? So what you have to do here is, in this case, right. So if you are going to do this manually, so I have copied all these values into an Excel sheet. You can see you have 25 observations, and in one set of in one group you have 5 observations. That is, actually this is sample 1, there you have 5 observations, right? This is like if you take day 1, you have take 5 pistons to measure the diameter, right? In the first piston, that is 74.03, in the second one 74.002, and 74.019 likewise, right? So what you have to do is, now since we are not given with the population mean and the standard deviation, we don't know what is the mu value and what is the sigma value. So I will write here in this case mean population, mean, and let's say population variance, they are unknown. So that is the first thing you have to identify when you read this question. This is very important, right? So if the population mean and the variance, if they are unknown, you cannot use those equations to construct this chart and the X bar chart. So that is, you have to select the equations, or you have to select the equations of the S bar chart, how to construct that without the population mean and the standard deviation. So that is, if you have a look, we know when the population mean and the standard deviation, when they are unknown, and when we want to construct the S bar chart, these are the final set of equations, right? So that is to construct the X bar chart, right? And if you want to construct the S chart, these are the final set of equations, okay? So in this case, you can say the center line is equal to the mean value of the sample variances, and the upper control limit B4 times mean value of the sample variances. The lower control limit B3 times the mean value of the sample variances. So what you have to do is then, if you are going to construct the S chart first, the first thing is you have to calculate the sample standard deviation values, right? So you can manually calculate, or else you can use the equation here to calculate. That is, if I show here in Excel, you can use the sample standard deviation using this formula, right? And since we have 5 values, I'm going to enter these 5 values here and give OK, and then you have the sample standard deviation values. So I'm going to do the same thing to the remaining. So this column will give you the sample standard deviation values, right? You have 25 values, but we are interested in S bar, that is the mean value of the sample standard deviation values. So since we have the sample standard deviations, now I have to take the mean value of these 25, right? That is, what I can do is I'm going to take the average value, so S bar value is equal to this 0.0094. okay, so now if you look at the equations, now the center line value we know, right? I'll write it here. Okay, I'll write it here. So the center line value is equal to 0.0094, right? So we want to calculate the upper control limit, and then we want to calculate the lower control limit. Okay, so if you look at the equation of the upper control limit, that is B4 times S bar. So S bar we know, now we have to find what is B4. So I'm going to look at the factor table. So this is the column for B4, right? Now you have to read the sample size. So here you have 25 observations, but each sample consists 5 values. So you have to take the sample size as 5, not as 25. You have monitored your process throughout 25 days by taking samples of size 5. So that's why you have to read 5 from the table. So when you read 5 from the table, and if you look at the B4 value, you have 2.089. So I will write the B4 value here, right? That is B4 value, right? So that is 2.089. Okay, so the B4 is known, that is we can calculate the upper control limit, that is B4 you have to multiply by S bar and you will get the value for upper control limit, right? So then if you look at the lower control limit, that is B3 times S bar. So I'll read B3 value from the table. When B3 value, when the sample size is equal to 4, that is equal to 0. Right? So you can read the B3 value as 0. This is B3. So the lower control limit is equal to 0. That is B3 times S bar, which is equal to 0. Right? So we have constructed values for the S chart. Okay. And I'll show the X bar chart control limits as well. Now when it comes to the S bar chart here, now since we have already constructed the S chart, so you can go with these equations to construct the X bar chart. So in that case, the center line is equal to x double bar. That is the mean value of the sample means. So if you look at my Excel, so you have x bar values here. So you can calculate the average of the sample values. That is the mean is equal to, you have these 5 values here. This will give you the mean, and I'm going to do the same thing for the remaining. So this column gives you the x bar values, the mean value of each sample. And in that case, I'm going to calculate the x bar value here, x double bar, right? So the x double bar value I can calculate, that is, I'm going to take the average values of the averages here. Okay, so if you look at the equations again, you can see when you want to construct the center limit, that is equal to x double bar. So we have already constructed that. So you can write the center limit is equal to x double bar, that is 74.00114. And now again we have to calculate the upper control limit as well as the lower control limit, right? So in this case, if you have a look on the equations, we can see the upper control limit is equal to x bar plus a3 times s bar, and the lower control limit x double bar minus a3 times s bar. So to do whatever, we have to read a3 from the table. So I'm going to read the A3 value from the factor table, and our sample size is 5. So the A3 value is here, that is 1.427. 1.427. So I'll write A3, that is 1.427. Okay, so here I can write, now upper control limit is equal to x double bar plus a3 times s bar is here. So this is the upper control limit, and if you look at the lower control limit, right, the lower control limit is equal to, if you take the lower control limit is equal to x double bar plus x double bar minus a3 times s bar. So these are the control limits. It's very easy to construct the control limits using a given data set and with the factor table, right? Same thing you have to do when you are constructing the R chart as well. So let's have a look on the equations of the R chart as well, right? So here right, so you can see the R chart is can also be so in this case, if you are going to construct the R chart when the population standard deviation is known, you can see these are the set of equations of the control limit. So as we read the factors, here you have to read factor D2 and factor D1 and factor simple D2. So likewise, you can simply read the factors from the table and construct these charts, right? So I think that is clear with you. And what you have to do is, now after constructing these charts, okay, you have to draw the control limits, right? You have to draw the control limits. That is for an example. Uh, Now here you can see we have received the control. When you take this chart, we have received the control limit, the upper control limit as 0.019 and the lower control limit as 0 and the center line as 0.0094. So if after finding these values, so this is my uh, this is my S chart. So you can see first you have to, here the lower control limit is equal to the x-axis because its value is 0, and here you can see I have plotted the upper control limit, that is 0.0196, and this is the center limit, right? And you can see first you have to observe the S chart before you go to the X bar chart, and you can see when you observe the S chart, all the data points are within the upper control limit and the lower control limit, that, and also it's having a random pattern, so we can conclude our process is in control. Then we go to the X bar chart. So when you go to the X bar chart, we got the upper control limit as 74.014, lower control limit 73.988, right? You can see these are the values, and the center line is 74.001. So you can plot these three values, and here you can plot each sample mean X bar value. That is, if you take day 1 sample mean value, here you have the sample mean value as 74.01. So with day 1 you have to plot 74.01 when you are constructing the X bar chart, and when you are constructing the S chart for day 1 you have to consider the sample standard deviation of day 1, that is 0.0148. So with day 1 here you have to plot 0.0148, right? So you can see when you observe the X bar chart for this case, there are also all the data points are within the control limits, within the lower control and upper control limit, and also it shows a random pattern. So there also we can consider the process is in control. So we have no problem with this process. But in case if you find the process is out of control, then you have to stop your work and find out the assignable courses for this out of control signal, right? And then we have to find the root causes as well. Okay, so I hope you understand how to construct the X bar chart, S chart, R chart manually when you are given with the data set by reading the factors from the factor table, right? So we will discuss furthermore in constructing control charts in the next session, and thank you so much.